This video is about rules of exponents and properties of exponents. And the worksheet comes from Matt's Math Lab with Gwinnett County Public Schools. Alright, so this is one property that deals with exponents. And basically it says this. If I give you x to the third power times x to the second power, I can add these exponents and call it x to the fifth power. The reason why I can just add 3 plus 2 and call it x to the fifth power, x to the third is really x times x times x. X to the second is really x times x. So when I multiply all that together, I get x times x times x times x 5 times. So it's x to the fifth power. Another property is this. It deals with a power raised to the power. If we got x to the third raised to the second power, that's really x to the sixth power. The reason why is I can multiply 3 times 2 and just call it 6. That works because x to the third to the second means x to the third times itself, x to the third. And you multiply it together, you get x to the sixth power. So the shortcut is simply multiplying these exponents. We have a power raised to a higher power. If I gave you x to the seventh divided by x to the fourth, x to the seventh expands to be x times x times x times x 7 times. X to the fourth expands to be x times x 4 times. You notice these x's are canceled out. Each one reduces to be 1 over 1. So when you cancel a number over itself, it leaves you with 1. So 1 is 1 over 1. What I have left is x times x times x, or x to the third. Our shortcut with this is, if I got a variable divided by exact same variable, I can simply subtract the exponents. So the difference between 7 and 4 is 3. I should know that x to the third should be on top of this fraction, because x to the seventh has a higher exponent and is at the top of the fraction. Here's a new example. Alright, so in this one I try to block out the answers for it. But it says y to the second, x to the negative 3 over z to the fifth, y to the negative fourth, z to the sixth, z to the seventh. So to simplify this, negative exponents mean they're on the wrong side of the division bar. So every one of these with negative exponents, I could begin by moving to a different side of the division bar. So if we wrote this, it would be y squared still on top. X to the negative 3 becomes to the bottom as x to the positive 3. Y to the negative fourth becomes on top as y to the positive fourth. Z to the fifth is already there. X to the sixth doesn't move, and z to the seventh doesn't move. And this is the new expression after I've dealt with the negative exponents. If we give you y to the second times y to the fourth, we decided we should add these exponents. So we give you y to the sixth, z to the fifth. That's going to be over x to the ninth, z to the seventh. From there you're looking for what you can cancel, and the only thing that has the same variable on top and bottom is z. What I'm looking for is, I got z to the fifth over z to the seventh. I would decide what the difference between these two are, and decide what the variable should be at. The difference between 7 and 5 is 2. And I got a higher exponent on the bottom, so there should be z to the second on the bottom. So my final answer here gives me these cancel to be z to the second on the bottom, and this becomes a 1. So the final answer for this one should be y to the sixth over x to the ninth times z to the second. Or just y to the fifth, y to the sixth, x to the ninth, z to the second. Let's reconsider this with all the scratch work. So basically, if you're going to simplify this, notice that they first replaced x to the negative 3 on the bottom and y to the negative fourth on top. They expanded y to the fourth, y to the second, z to the fifth, x to the third, x to the sixth, z to the seventh. They expanded it out the long way. And they canceled all the things that they could. And when they canceled, some of the z's canceled. And that was about all though. You got 1, 2, 3, 4, 5, 6. You got y being multiplied together 6 times. X apparently 9 times. So you got y to the 6th, over x to the 9th, z to the 2nd. Let's go to a new one. This one says simplify 3x to the 4th times 2x to the 3rd. Or to simplify that, you should multiply 2 times 3. And you should multiply x to the 4th times x to the 3rd. 2 times 3, you should know that's 6. X to the 4th times x to the 3rd, you should know that's x to the 7th. So our answer is 6x to the 7th power. In the next example, it gives you 10, and then a to the 4th, b to the 7th, over 12, a to the 8th, b to the 5th. These numbers are both even, so they're both divisible by 2. So divide both by 2, I will get 5 here and 6 there. So my top number have a 5, and my bottom number should be 6. A to the 4th over a to the 8th. In this case, they both have a's, and this has a to the 8th power. There's more a's on the bottom. So the difference there is 4, so I can call that a to the 4th. And think about this, b to the 7th over b to the 5th. How many b's should you have left over after you divide them? And where should the b value be after you divide them? Think about that. It makes sense to call it b to the 2nd on top, because the difference there is 2, and they have more exponents on the top. So my answer here is here. On to the next example, where I have 5 p to the 4th q to the 2nd squared. If you expanded that, that means 5 p to the 4th q to the 2nd times 5 p to the 4th q to the 2nd, which is simply written as 5 times 5 is 25, p to the 4th times p to the 4th, and q to the 2nd times q to the 2nd. 5 times 5 is 25, p to the 4th times p to the 4th is p to the 8th, q to the 2nd times q to the 2nd is q to the 4th. You could have did it this way too though. That's the way you can do it expanded with the expansion, and that is the right answer for it. Or you could simply square each one of these numbers. 5 squared is 25. P to the 4th to the 2nd, we decided we should multiply these exponents. So that means p to the 8th. Q to the 2nd to the 2nd, you have to multiply those, you get q to the 4th. It's the same answer we had here, except you have fewer steps by just knowing the property of just squaring each one of those numbers, which means you multiply the exponents and just square the number. Try another one. Here, what we have is 4t to the 3rd v to the 2nd times all these things. I'm going to multiply this together as I see them. 4 times negative 8. I'm going to put that in parentheses instead of with a dot. That way I can see as multiplication and not division. T to the 3rd times t. V to the 2nd times v to the 2nd times u to the 0. Think about what that is. Well, what is 4 times negative 8? What is negative 32? What is t to the 3rd times t to the 1st? As I understood, 1 is an exponent, that's a t to the 1st. We should get t to the 4th. What is v to the 2nd times v to the 2nd? We should get v to the 4th. And u to the 0, we should just know any number to the 0 power is always 1. So our final answer is simply negative 32, t to the 4th, v to the 4th. Try a new one. Here, pause the video and try this one on your own. One way of doing it, you could have expanded it. If you expanded it, you would get negative 3 times negative 3, where this whole thing times itself, times here. So negative 3 times 2, this is 9 times 2, so that's 18. M to the 3rd times m to the 3rd times m to the 2nd. We're going to add up 3 plus 3 plus 2, get m to the 8th. N times n to the 4th. N times n is n to the 2nd, times n to the 4th gives you n to the 6th. So the final answer for that one is this. The last one is this one. Pause the video and try this one on your own. If you tried it, you should have thought to divide both of these numbers by a number that can divide into both of them evenly. I think they're both even, so it should be at least divisible by 2. But it might even be divisible by 6. 6 goes in Alvin 3 times. 6 goes in 24 4 times. So the top number should be 3, and the bottom number should be 4. A to the negative third is on the wrong side of the division bar, so it goes to the bottom. So it's going to be a to the second times a to the third down there. On the top, b to the second over b to the fifth. It should cancel to be b to the third on the bottom. C to the sixth over c to the fourth should give you c to the second on top and 1 on the bottom. So just c to the second there on top. And now, if I finish this, it's 3c to the second over 4. A to the third times a to the second will be a to the fifth times b to the third. That's the final answer for it. If you feel like you need more practice, you can try these. So you feel like that was enough practice, you can copy those and give them a shot on your own. That's all I have. Good luck.